In this video, you will see a focus on pattern recognition. As a teacher, you will naturally bring together many computational thinking strategies in your lessons. Once students are familiar with naming each of the computational thinking strategies, we encourage you to look for opportunities to bring them together. For example, there are also opportunities in this video to identify debugging.
Favorite pattern recognition, CT practice, thinking strategy, because I love patterns.
Oh, okay.
And did you know that your brain really looks for patterns in life?
Yes.
It's a survival technique. It's just very natural. So you have been looking for patterns probably since you were a baby. And now what you want to do is you want to harness that and say, how can I look for ways that problems or solutions or parts of stories are similar or different to help me solve other related problems? So you look for things that are similar or different, and then you use that to help figure things out. First thing you ask is and again, I'm going to take out the word problem because I don't like problem. Story. What does a story or situation make me think of? So when we're on the treadmill, you're going to see information and stop and think, well, do I ever look at information like this in any other situation in real life? Then we're going to think about stories or problems or questions and their answers and think about how they're alike and how they're different. And then the last, we're going to see how using this pattern recognition and seeing these similarities, it sparks some creativity and it helps you figure things out. And it helps you maybe see different solutions. So the focus here on the math, not so much this, but the math part, luckily we're using something that we've been doing before, which is talking about ratios. A unit rate is a ratio. And it's a ratio where the second piece of information is 1. So give me your unicorn head. Unit, which is 1. So when we look at a unit rate, we want to bring it down to something per person. If I ask how many bookmarks you have, we say it's 1 per person. If I say how many highlighters do you have, the unit rate might be we have 2 highlighters per person. Does that ring a bell?
Okay.
I'm going to say I have a green dot.
And a yellow dot.
And that's similar
Or like
and
blue.
yellow as different.
And then you want me to use yellow as different?
Uh-huh.
Okay,
Yeah.
so what if I use orange? Because orange is a little easier to see.
Yeah.
I know I often use yellow, but orange is easy.
So like red. It's like partially.
Orange makes me think, something's different.
Like slow down.
Yeah.
Yeah.
All right, so we're good. So it says some students did treadmill workouts, each one running at a constant speed. That just means that they're just running, and then we measure their speed. We measure speed, for those of you who might not remember from science class. Speed is how far you go divided by how much time it takes you. Can you think of different examples where we measure speed besides a treadmill?
Length.
Length is, we think of length as that distance. So when we measure it, we're using, it's a linear measurement. But can you think of another time when you measure the length of your travel and how long it takes you to go? You did something recently where the speed was really great because you had to flying, right? So do you think that in order to plan an airplane trip, the people who are planning at the airport need to know the speed of the airplane?
Yes.
Okay, so that's a good example for when we are looking at constant speed. Another one?
Car.
In your car. So you don't get a speeding ticket?
On a bike.
On a bike, so you know how long it will take you?
Skateboard.
On a skateboard? Ooh, in case you're having a contest. I can only take one more, eeny, meeny, miny, you. Yes. Roller skates. So that's something you're familiar with. Pardon me?
On a Hot Wheel.
On a Hot Wheels. Oh, I love Hot Wheels. Okay, I'm glad you shared. So now what we need to do is we need to really hone on pattern recognition, and our 2 main ideas are on your worksheet. We're looking for things that are what?
Similar
Similar
or
and
different.
different.
Good. So in the questions, it asks us questions just related to that, directly related. What is the same about the way the students recorded their workouts? What is different about the way the students recorded their workouts? So I'm going to read it. You can just read along. It's on your sheet. Are you ready? Should we do a little Swiss cheese reading?
Yes.
All right. Tyler ran 4,200
Meters
in 30
minutes.
Oh, I need to switch something here. Let me get my writing tools. This is where Ms. Frankowiak made some sort of a mistake. So, half an hour. You can write that on yours. But let's start from the beginning of Swiss cheese. Ready? Tyler ran 4,200
Meters
in 30
minutes.
Kieran ran 6,300
Meters
in
half an hour.
Mai ran 6.3
Kilometers
in 45
minutes.
All right, on your sheet, can you please take green and can you connect things that you see that are the same? And for your other one, if you just want to put the thing, and you could just put S for same. You want me to help you out with that? Okay, so then I would circle that and make sure that they connect. Oh wait, you know what? Oh, no, it's okay. Okay, anything else that's the same? Yep. And I'm going to walk around and see the others. Ooh, it's looking good, it's looking good. You are good detectives. You are great detectives. All right, and now before we do that, I know I'm excited to hear your answers, but do you think you could jump right into 2?
Yeah.
So switch your marker colors to match your key.
Here, the teacher provides students the opportunity to work together and build from one another's knowledge and experiences, and to share their work with the class.
All right, so we already talked about what this story makes us think of. Airplanes, cars, roller skating. Again, a rate where we're comparing 2 different quantities. We are looking to see what is the same and different, and I don't even know who to call in first. You've got so much. Okay. All right, Alinice, do you want to give us a same or a different?
The same.
Okay, what is same?
That. Oh. Wait, is that right?
If you want to, otherwise I can be your scribe.
Oh, okay.
Ooh, minutes and minutes. Excellent. Okay, Ruby Serna.
Different.
Okay, do you want me to do it or you? Okay. I'll give you orange. Ooh, good eye, good eye, good eye. Daniel. Is this going to be same? Okay, so there you go. Okay, see what happens when you're patient?
I was gonna
Yes.
tell her the half an hour and the 30 minutes because they both equal the same thing. Half an hour.
Okay, so you know what I'm going to do with that? I'm going to take charge, and I'm just going to highlight that. Boy, is that a mess, right? But it's a good mess. It is a really good mess.
It's a talented
because
mess.
it's a what?
Talented mess.
A talented mess. I love that. And you know what?
A beautiful mess.
If you did this more often with your math, if you actually just like dig in and look and see what's there and make it, dig into that mess, you're going to find that it's not as hard as you think it is. The similarities that we see up there, do they give us ideas about how we can solve this? Do you think it's going to be easier to make comparisons if we work with the differences or the sames?
The same. Differences. Same.
You know what? I'm going to override you just this one time, and at the end, if you don't agree, I'm going to come back and ask you to convince me, okay? What could we do to make this easier? If we've got green sames, and then we've got orange differences. Do you think we can take any of the difference and move them into the same category?
Yes.
Yes or no?
No.
Yes.
Maybe.
I'm going to challenge you. Minutes and hours. Can I make those the same?
Yes.
Yes.
They're
No.
both
No.
time.
Yes. No.
They're both time.
Right, but they're both time, but are they both the same units?
No.
So when we measure time and time and speed and distance, I'm getting mixed up. When we measure speed, we usually say we're going so many miles per
Hour.
So could we move this over here and so that we both got hour? Hour. All right. Meters and kilometers. Could we move those over here? We could. How many kilometers are in, or how many meters are in a kilometer? There's 1,000. But I don't know how big that is, so I want to work with meters. So we could change that both to meters. And then the last thing is these numbers here. 6.3 and 6,300.
Add 2 zeros.
We could make them both. Okay, you want to do that? We can make them 6,300. Oh, I think we'll have to do some math there to figure that out. I think we'll have to change the kilometers to meters first before we do that.
Here, the teacher encourages students as they work on the problem to use an approach that incorporates computational thinking. The teacher provides students the opportunity to work together and to build from one another's knowledge and experiences, as well as to share their work with the class.
So, A, B, C, A, B, C, A, B. B goes first. So, Ruby and Annalise, what was the same? We're going to focus with similarities, not differences right now, but similarities.
Karen and Mike are the same because they have the same number, but like different, like this. They have one of them, but I know they should kind of fast, but this is different. But
I can give you a word to help you. Numerals. Okay.
Okay, and they both ran.
Okay. So if we're thinking about what's important for math or running, we can do away with. But I heard you say numerals, and I hear 6.3, and then this would be either a comma or a decimal. Does that express it?
Yes.
All right. Excellent. And thank you for reminding them that we can look for differences, but right now we're on the sames because the sames are what's going to make this easier at this point. Go ahead. I can't even remember your name sometimes. Do you want to go up there and help us? Bless you.
Thank you.
Do you need a tissue? Okay. There you go. Just go.
Are they thinking about you?
Oh, they're making us wait. They're not even telling us what's the same.
They both ran in minutes. Sorry.
Oh my god.
So that's Maya and Tyler. They both run in minutes. All right, excellent. So now look at this. That is a really good observation because someone else might say, well, those are different. If we don't look carefully enough, we might not see that the minutes is the same, even though there's a different number of minutes. Excellent. And now, there is a lot more that we could talk about, but I want to ask you, do you think that these similarities give us ideas about how to go ahead and solve or answer the question?
Yes.
Do we need to be afraid of it because it's not the same?
No.
No. Because we focus in on the similarities first. So we could probably make some really good statements up there. I'm going to add one more thing. Is that okay?
Yes.
So I see for Tyler and Kieran, and this is just because I did not grow up with this kind of clock. I grew up with a round clock. And so I know really clearly that in Tyler and Kieran, this half hour, that's the same amount of time.
Oh yeah, I forgot about that one.
Oh yeah.
I said that on the last one.
And you know what? That probably would have become clear to you once we move past similar and then you go to looking for the differences, right? So we are going to divide this lesson into 2 days because this is an extremely long lesson. But when we come back, can you just, how would you explain to me, like, how are we going to attack this with pattern recognition? What are we going to look for?
The differences.
And sames.
The differences and the sames, and
Or similar.
or similarities. And then if you remember what I wrote on the board, if we see similarities and differences in the beginning, if we're really good and we're doing the math, do we have to keep the differences different? No, we can look for ways to move them to the similar category. Because remember that when we make comparisons, we cannot really compare two things that are different. If I were to compare the math that you know with the math that 8th graders know, would that be a fair comparison?
No.
No, I would say, well, their grades are too different. But I could say, well, what about when they were in 6th grade? What did they know? Then I move it to the same. So the whole idea here is to look at things that are different and see if they're getting in the way and see how we can move them to the similar. Does that work?
Yes.
I'm sure you do that with outfits, right?
Totally. Yes. Every day.
Like, these colors are too different, but if I bring in a similar color, I think that makes a better outfit. All right. Put your hands on your head. Hold in your pattern recognition until tomorrow. Ready? Pattern recognition. Good. All right.
Make it into jelly.
Thumbs up or thumbs down or thumbs to the middle for the math part. I'm going to say this because there's a lot more math we need to do with the numbers. What about this part, though?
Totally.
Oh, yeah, some 2 thumbs? All right. Excellent. We are good. If you could put your materials away.
As you plan to frame, prompt, and highlight computational thinking within your lessons, consider the following questions. What are some strategies my students could use to solve the problems in this lesson? How might a CT strategy already be part of or add to those strategies? How might I recognize when I see my students using a CT strategy? How might I identify when it would be helpful to prompt a student to use CT?